Okay, folks, GM everyone, we are back for day 9 and today we are learning liquidity pools. Now, this is where things start to get complicated and complex because liquidity pools are the contracts and mechanisms that actually give each token its value against the dollars or whatever real life asset you want to trade in, or except it could be another token too. So how does a liquidity pool work? There is a great video from crypto whiteboard. Let me just give you the link. I'll drop the link in the description. It is a very graphical video. This is the video. They have explained it great, so I'll explain it as best as I can. So imagine this mixer, okay, where you can deposit either token A or you can deposit token B, right? So two people, let's say P1 and P2, both have deposited 50,000 of, so 50k, and P1 has deposited 50k and P2 has also deposited 50k, each of one currency. Let's say this guy gave A, this guy gave B. Okay, now this guy has given A and this guy gave B. So let's just write this down here. Okay, so now this magic mixer has, let's say, 25000, what is 15 to 50,000 into 50,000. So this is the value that we have here. Copy, and this is the value in the pool. Oh, let's keep it simple. Let's keep it 100 and let's keep it 100. Okay, just for easy calculations. The actual deposited value is very high than this, so 100 and 100. So this has 10,000 of ratio of A and B. So total tokens present in the mixer is 10,000. Okay, now let's say each token, so each A is priced at each B. So you can have one A and that will be equal to one B, because number of A is equal to number of B. That's understood here. That's very simple. So 1A will always be equal to 1B. Okay, so now let's say a person called P3 comes here and he or she wants to deposit 10A more. 10A. Okay, they want to deposit 10A into this magic mixer. Okay, now the total amount of A will in B, so total A 110 and total B will be equal to 100. So this disrupts the ratio. Okay, it will not be equal to 10,000. We want this to be equal to 10,000. Okay, so the main principle in this magic mixer, which we will call as liquidity pool, is that we have to maintain this ratio. Of course, this is something that is very primitive and old age mechanism, but this is what fundamentally a liquidity pool is. So it has a formula is equal to X into Y is equal to K. X defines the number of A tokens, Y is the number of B token, and K is this 10,000 ratio that we have. Okay, so 110 and 100. So now what do we have? So we have 110 into Y should be equal to 10,000. Okay, so now to calculate Y is equal to 10,000 divided by 110. So let's calculate again. 10,000 divided by 110, which will be 90.90. Okay, so this is the value that we need here. So Y should be equal to 90.90. Okay, so 90.9, that is Y can be equal to 91. Okay, so currently we have 100 B here. We want the pool to have only 91 Bs, so we can give this guy back 9 B. Okay, so this guy deposited 10A and got 9B back. So So this is something that you do actually, as in ETH, Bitcoin, everything. You deposit some dollars and you get your Bitcoin, whatever, Ethereum back. So this is how pricing is done essentially in real world for a basic scenario. It's just an ideal world, no slippage, nothing. So this guy got 9B, right? Now what is the price here now? So there are 110 A's for 90 B's, okay? 91 B, sorry. So now each B, so price of 1A will be equal to, price of 1A will be equal to 0.91B. So 1A will give you 0.91B, not the complete B. So 1A is not equal to 1B. The price of B has increased from A. So that is, B is in less demand, less supply and more demand, and A is in more supply, less demand. I hope this was simple enough to understand. This is the principle that we are going to build our system here. We'll deploy two ERC20 tokens and we'll put them in this pool thing. And when we put them in the pool, we will then transact through them. Okay. So I guess this is where we actually start our coding. So let me just spin up a terminal and we can then get to this. It's here, so let me take this here. CD developer, CD 15 days. Oh, we don't have it. So all the code here is present at this repository, which I link to in every video. You can get everything from here. So git clone, boom, and CD 15 days. Okay, let's forge in it for day 9, and at day 9, okay, and cursor day 9. Open it up. Yep, it opened up. Let's close this. Now we'll delete all these files. Okay, and let's delete these files. Let's open up, close it. Let's go for tokens.sol here, and then we'll have another file called pool.sol. Okay, now what we will do is we will create two ERC20 tokens, so token A and token B, okay, with same supply, and mint them to two different persons, okay. These persons will deposit in pool, whatever, for same supply, okay, same supply. Then we will transact on that. Okay, this is fundamentally what we are trying to achieve today. So let's start with the first thing, token A and token B. Okay, so let's just clone the OpenZeppelin here, and where is the OpenZeppelin code? We'll go here and let's get back and / no commit, and let's add the remappings here. I think this is the fundamental process for each day. Remappings is equal to boom. This is what we do every day. So now SPDX license identifier ID and pragma solidity, let's keep it a higher version today. Import ERC20.sol, and we will have two addresses today. On two addresses we will mint those two tokens. Now let's think about this. So we need two entities who have those two pools, and so basically something that does this today is called Uniswap. Uniswap is the DEX. This is called decentralized exchange. So in primary exchanges you have something called market makers who put orders to vary the price, etc. But decentralized exchanges always have AMM. Okay, AMM is the algorithm. This is called an AMM algorithm here, which actually simulates the price for you and everything here. Okay, so let's write, we need two contracts here. Contract token A is ERC20. Okay, and let's give it the constructor it needs, and the constructor, so it will be, we need an initial supply here, UN256 initial supply, and then we need an ERC20 constructor with name token A and comma TKA. Okay, and we mint the supply to the guy calling this. Okay, and then we have another contract called token B. I'm putting all of this in same file. We can do that, just use while deploying. We'll keep things separate. So constructor UN256 initial supply, and we have this ERC20 token B and comma TKB. Okay, and we mint message.center the initial supply. So these are two tokens that we have now. Okay, now we'll write the pool contract. First we need to deploy these two tokens and get their addresses. Okay, so let's deploy them on Anvil today. I don't want to interact with Sepolia that much because we are deploying many contracts. So this is our Anvil. Let's set up a .env. Okay, RPC URL is equal to HTTP, and thus now token A key is equal to this, and token B key is equal to this guy. Okay, now this is everything set for deploying the two tokens. Now this pool contract that we have will need the IRC addresses of token A and token B. So we'll also have the reserves for them, and on providing the liquidity, so we'll have two functions. So there is a deposit function in the pool for now, and then there is, so when this initial deposit is done, when the pool is empty, so that's okay, and then we'll have an add liquidity and remove liquidity. So swap A for B and swap B for A. So this is what we need here. Let's take a second and think of this through. Okay, so I have come to the conclusion that we don't need two wallets. We can actually deploy from one wallet and then interact from the other. So let's keep this as private keys. Okay, and this pool.sol, let's now start writing pool.sol. Okay, SPDX license identifier MIT. Now the main objective of writing this pool is that we can deploy two tokens into this pool, so that we can swap each for each. Okay, so let's say pragma solidity. Okay, just a second. Okay, sorry. Yeah, okay, now we are going import ERC20, but instead of this we need to get the interface of ERC20. And now let's say contract simple liquidity pool. Okay, and now here we can get this address. So we need two addresses of token A and token B. So it will be ERC20. Oh damn, this wrote everything. Let's get it out. Okay, and now we'll need the UN public reserve A and reserve B. So u into 56 public reserve A and reserve B, and then the total liquidity here. Okay, now constructor will give us address of token A and token B, which will pass it here. Okay, now function provide liquidity will give us the money here. Okay, so u into 56 amount A, u into 56 amount B, and they can be called externally. Okay, anyone can call it. And what happens in this is, so we need, let's make some errors first. So error amount must be greater than 0. Okay, now if amount of A amount B is equal to 0. Okay, now what we need is token A dot transfer from message dot sender to address this. Okay, address this, and comma, how much of it will be transferred? It will be transferred as amount A. Okay, now reserve will need to have the amount A and amount B added to it, and token B and reserve A amount A, reserve A amount B. Okay, so total liquidity will be amount A plus amount B. Okay, what is the problem here? Oh, we need this. Okay, we need this. This should not be this. I think it should be multiplied here. So now let's get this. Okay, so function would be swap A for B and swap B for A. So we have two functions here, swap A for B, and then we have, let's close that and we'll write it later, function swap B for A. And similarly, as we go by, so as we get price of A and B, function get price of A for in B, and similarly we have get function. Okay, and then we actually want an amount out here. Okay, so what does amount out gives you? That how much will you input and how much will you get out of the pool. Okay, so let's give it a second and think about this. So the first thing that we need is swapping A for B. Okay, so we need an amount of A. So how much A you are willing to amount A, how much A are you willing to deposit, and this will be a public call, or it will be an external function. I guess that's the best way to do this. And this will go back here, and then we lead amount u into 56 amount B is equal to amount A into reserve B by reserve A. That's what we did here, amount of A into amount of reserve B divided by reserve A. Okay, and then the first thing that we have to figure out here is, if this amount of B goes, then what is the liquidity here. Okay, so we need to transfer A first and then give back the amount of B. Okay, so get amount out. Let's make this a function. Okay, let's make this a function, token dot transfer from and token dot transfer message dot sender amount B, and yeah, that's cool enough. And reserve B gets minus and reserve E gets plus. This should work here, as we need no, we need u into 56 amount B that we are willing to provide here. This will be the complete opposite of this function here. So amount A will be equal to amount B into reserve A by reserve B, and this is what the function looks like. So this will be external view, and price to avoid reserve 1 to E18 divided by reserve of B, and similarly this gets here, and we get return price return price, external view returns even to 56, and address also returns even to 56. Let's remove this comment here. Boom, that's it we need here. And okay, I think this contract is ready for us to deploy. I'll just review this. Let's get this reviewed by ChatGPT. Let's go. It's basically we can use AI to solve a lot of problems that we face every day in writing contracts, some little bugs that we have missed. So I would recommend using AI whenever you can, and not completely relying on it, but also taking advantage of it. Is this pool contract completely functional? Nope. Wow, see, this is called something that we have. Okay, yeah, we need to understand what is an MEV sandwich. We need a minimum amount out. Okay, yeah, whatever. We should be provide liquidity. Yeah, that's what we can do this here. Yeah, okay, boom. Yeah. Yes. Let's do that. All. No. This is doing something complex, which is LP tokens, adding remote liquidity, fee on swaps, slippage protection. We are just doing this as a normal pool here. So I think this works well enough. Okay. This gives everything that we need here. And I just said in the start of that video that this is an ideal world where there is no MEV sandwiching, there is no people trying to rob off this pool. Okay, so I'll show you how to deploy this pool, and then we can work on how we can actually increase the security of this pool. Okay, so let's close this here and we see if we have done everything. So now let's deploy this. Okay, tokens not sold first, so let's go for clear here, forge, create, cast ERC20 balance. Okay, I want to see how to go for cast balance here. Balance of ERC20. Yeah, we can do that too. Okay, so let's create the token A first. Okay, let's source the ENV. I hope the screen is visible enough. I can up the zoom a little bit. Yeah, forge create, SRC tokens, token A, and RPC URL, $RPC URL, private key, $private key, and broadcast this transaction, no arguments. Oh, initial supply. We need an initial supply here. Okay, so what could be the actual initial supply here? We can give it an initial supply of this much. So let's go and let's go to constructor args and let's give this much initial supply. Okay, and this token is deployed here, so let's hold this here. Token A is equal to this. Okay, now let's check the balance of the guy, balance of this, and let's see how to get the balance out here. Cast balance ERC20, and this is what we need here. Okay, the address of this guy, So this is the first key that we use. I always use the first key. So this would be the balance and RPC URL, RPC URL. Okay. Balance / ERC20. This is the flag, right? Yeah, ERC20, ERC20. Okay, that is the initial supply that we passed. Now let's write the same thing here again, cast create, and this time we'll go for token B. Okay, and we'll deploy token B to the same private key again, and let's see this now. Token B is equal to this. Okay, let's check the balance now. Okay, we have checked the A balance. Now let's check the B balance here. Same. Okay, now we have same balance here. So this guy has 1 tens 100,000 like 1 tens 100,000 1 million of token A and 1 million token B's. Okay, now we need to deploy the pool first with these addresses. So let's source the .env again. Okay, and for deploying the pool, I am thinking of using another private key, which seriously won't matter because there is no only owner function here. Deploying a pool would be not a big deal, but let's do that for our mental peace. Let's say pool deploy is equal to this guy. I hope it's not same. Yeah, it's not same. Let's source the env again, and will be force create ERC /pool, and we'll go for simple liquidity pool. Okay, and RPC URL. Oh, we need the constructor args, don't forget that. Okay, private key. There is something that I came across yesterday, which is called cast for private keys, I guess. Encrypted private key Foundry. I found this yesterday. Cast wallet import. So this is very important, and you can get a new wallet and you can use the private key without having it in this .env file, as these get stolen and stuff. So I'll do it in the next video we came across. Now I'm thinking of from day 10 to day 15, we'll make one good project with a good front end, multiple contracts written. So I'm thinking of a good idea here that we can use and we can make a good project. Okay, so to ensure, if you have any ideas, drop them in. Constructor args, and oh yeah, what we had to do in the constructor args, sorry, I just forgot. Yeah, so this is the token A and this is the token B. Okay, and private key would not be private key, it will be pool underscore deploy, and the pool is deployed here. Okay, the pool is deployed here, so pool address will be pool is deployed here. Okay, now transaction hash is found. So now we need to approve the tokens here first. Okay, so we need to approve the tokens for being sent from this guy to this pool address. So how do we do that? We again call the cast and then we see if we can do that. Okay, so let's see here, and let's approve the tokens first, and then we will ensure that we are providing liquidity here. Okay, are there any getter functions in there? We have 0 for now, and let's keep it like that. So let's get back here, and we will first call the approve here. So send dollar token A, that's what we have written here, right? Token A, and then we call the approve function. Okay, and we need an address and an amount, so u into 56 and let's say the address is the pool. Okay, let's just source the env first so that we get the pool address here. Cast send token A, approve address and U into56. The address will be $pool. The amount will be, let's say, 50,000 tokens here, so 50,000, and RPC URL $RPC URL private key, and we have $private key. Okay, this is the first transaction that we go through. Yeah, and then let's call the same transaction for token B. Okay, then we'll be able to provide liquidity. Yeah, so both the tokens are approved now, and now let's call the pool address. Cast send $pool, and we are going to call the function for providing liquidity. Okay, so provide I did not copy that. Provide liquidity. Now we need amount N, amount B here. Okay, so U into56 comma U into56. Okay, now we'll use 50,000 and 50,000 here. RPC URL and private key with $private key. Okay, that's cool. So this will give us the transaction goes through. Now let's check the balance of the pool. Okay, let's check the balance of the pool here. Let's close this guy and let's see the balance. So it has 50,000 tokens here. Now let's call the functions for get price of A and B, and let's get the price of A and B. So cast call pool, the function is called this, and it has no parameters, but it returns U into56 and RPC URL, so that is equal to 1. And let's call the other function here, price of B in A, same price. Okay, so both are priced at the same thing here. Now let's swap some A for B, and let's swap for some B for A. Okay, so we will swap, let's say 100 of them. Okay, so we need to approve them first, so let's approve A again. Not 50,000, let's make it 1,000. Okay, we'll send this much token to pool. Okay, that's cool. And now let's swap A for B. Cast send pool and swap A for B, and the amount is 1,000. Okay, and then we get we call the RPC URL and $RPC URL private key private key. Okay, what's the problem here? Cast and oh, sorry guys, sorry, it takes a U into56, and let's send this transaction. So now let's check the pool again. Let's check the pool again for token B, ERC20 and $token A. Token A will be more, we have 1,000 more tokens here. Now when we call the price function, get price of A and B, it will be lesser than the B. So token A are more and token B are less. So let's see the price here. Okay, get price of B in A, which will be more than that. Now let's see if the guy who actually put some A got back some B, right? So cast balance ERC20 $token B, and the address that we need here is this guy. Okay, this guy, oh sorry, I didn't copy that. Yeah, this guy, remember he sent 50,000 B to that, so he should have 50,000 more. RPC URL dollar RPC URL. Okay, but he has some more tokens in that. That means that he got some back. Okay, now let's swap some more A for B. Okay, let's approve some more. Another 1000. Yeah, another 1000, and let's swap A for B for another 1000. Okay, now let's get price of A and B. The price of A keeps decreasing against B, as you can see, and the price of B gets increasing. Now let's see the balance of B. So they got 1996. So when he sent the 1000 first, he got 1000 back, and then again he sent 1000, then he only got 996 back. That means the pool price of B is increasing and the pool price of A is decreasing. So guys, that's the video for today. This is a very simple pool, as GPT just told us that this has a lot of breakage here. So in next video or the next project that we do, I might explain the topics like slippage, what are some different things that we need, but everything can be seen in this video that we have here, the whiteboard crypto video, which I'll link to. And that's all for today. Thank you for watching.